Hey guys, I found this relatively old file on my computer and I guess there's a cool technique to share. So what does it do? It pushes away these instances of curve objects from these surrounding objects. In this case I use spheres, but you can use any other objects, and this is useful to create this sea anemone effect I have here, or for example to push away grass under the feet of a character. And there are some techniques I've seen online, but all of them take only a single object's position into account and not the surface of the objects or even multiple objects. So yeah, let me show you what I've did to achieve this. So let's start with a little bit of theory. Let's imagine we have a curve object here which consists of multiple points. And then we have another object with a surface. And this surface has kind of like a force field around it, which should push away these vertices I have here. So how do we get the direction? It may go like this for this point here. Let's call this point 1. And to get this direction, we simply have to know the closest point on the surface of this object here. So it may be this point here. Let's call it point 2. And then we only need the vector between these 2 points. And to get the vector, we only have to subtract point 2 from point 1. So v equals point 1 minus point 2. And then we can even normalize this vector to make it a consistent length of 1. But we don't have to. It depends on the use case. So yeah, knowing this formula here, we can start with the geometry node setup. So here's a fresh new Blender file. I delete everything. Then I add a sphere and I create a geometry node setup for this sphere. And I want to instance some lines, so I use an instance on points node and also a line curve object. And to create these points, I simply use a distribute points on surface. And I want to display the instances and the sphere, so I use the join geometry node. And here we can see them both. And to get the rotation of the instances facing in the direction of the normals of my sphere, I can simply plug this rotation in my instance on points node. Next we can maybe shade this thing smooth and switch to a matcap view. I like this one. And also I want to increase the density of my instances. Yeah, so that is step 1. Then we need some objects to push away these curve objects. So we can use icospheres or maybe cube or even a monkey. So I choose the Suzanne mesh. And then to get a reference to all of these objects in my geometry node tree, I move them to a separate collection, and I call this collection push. And right now I can get a reference to these objects with the collection info node. So here I choose the push collection, and if I take a look and disable this here, you can see that we have these objects now in the geometry node tree. Then it's often a good practice to use a realize instances node after the collection info node, and this only makes sure that all of these objects are kind of like applied in their scaling. So some objects may have a different scale. You can see it here. And this realize instances node takes care of that. So it's kind of like applying the scale here. So yeah. Next we do the same thing for our instances. So our calculations that we do are individual for each of these curve objects we have here. And then we give the lines a little bit more geometry. And I do this with the resample curve node. And I increase the count to 20 in this case. Yeah, so now we have the realized instances here. And here is our collection that should push away the points of our instances. So yeah, we have to remember our calculation. So we need the vector to the closest surface, and we get the point of the closest surface with the proximity node, geometry proximity, and this here is the target, and it is set to face, and that's where we leave it. And here we have the position. So we only need to get the position node, and this gets us the position of each of these points of our instances. And now we take a vector math subtract node. Subtract vector math, and then we subtract this position from the original position. And if we now take a set position node and use this vector for the offset, we see something strange is happening, and this is because all of these points are getting pushed away independent to the distance of these objects. So we want to take the distance into account, and luckily we have the distance with the geometry proximity node. And to control the strength of this vector here, we can simply use the scale vector math node and plug the distance in it. And right now it looks even more messed up. And this is because the distance increases the farther away the object is, and so the displacement increases, but we actually want the opposite. So the farther away the object is, the less displacement we want. So we actually want to invert this distance here, and we can use, for example, a map range node for this, and this also clamps this value, which is very useful. And in this case I only invert these values here. So we have kind of like this effect, and you can already see what's happening. These strands are getting pushed away from this object here. And to control the strength, we can change like this value here. Yeah. So to make it a little bit more visible, we can make these curves solid. So after our set position, we use a curve to mesh node with a profile, and I choose a circle curve and toggle fill caps, and I decrease the radius a little bit. So yeah, maybe like this. Yeah, so you might not see it, but there is a problem here at the base of our curves, and the space gets also displaced, but I want it to be fixed on the surface of my emitter object. And for this we can use the curve factor, which we can access with the spline parameter node. And then I want to scale the strength of the displacement vector by the factor. And the factor is simply a value which goes from 0 to 1 for each curve. So at the base it is 0, and now only the top of our curve object gets displaced. So this is already a cool effect, but it doesn't look really right and gives us some errors like here. And I found that it's good to rotate some of these instances based on the distance. And yeah, let's do this. So we do all these calculations here in our rotation, and we want to take the collection info node. We can make a connection from here, but I can also just duplicate it. And again, we need a proximity to the position of points I have here. So I can simply copy this setup I have here. And now I want to align all of these instances to this vector we have created here. And for this we can use the align Euler to vector node, and we want to align this rotation here. We set it to the Z because that's what we need. And if I plug this vector straight in here, you can see what's happening. And it kind of reacts to the surrounding objects, but it's really extreme, and that's because we don't take the distance into account. And here with the factor you can see that they kind of rotate away from these objects. So this factor is really important, and here we can simply use the distance for the factor, and of course we have to invert it again. So I use a map range node and do the inversion here. You can do this with math node too, but in recent projects I tend to use the map range node more often. And yeah, you can already see that these instances are getting pushed away. And for the strength or the influence of these objects here, you can again use this value here. So if we now take a look at both deformations, so first the rotation of instances and then the displacement of the points on these instances, we have this cool effect. So of course we can adjust it a little bit. So in my experience, the value here shouldn't be too extreme, so only a slight rotation and also only a slight displacement here. And let's test it again. Maybe we can increase the density here a little bit. The viewport is kind of slow, and this may be because geometry is a little bit high. So let's lower it a little bit. Don't need it to be this high. Now I should be able to increase the instances even more. Yeah, so gives us this nice effect. And if you put the instances straight on the UV sphere, you see this weird pattern happening here. And we can simply add a little bit of random rotation to all of these rotations we have here. So I simply use a vector math add node and a random value. And we set the value to -1 to 1. And with a combination with a scale node, we can control the strength of this random rotation. So I add this to this here. can see that we now randomize it a little bit. And now it should look a little bit better. Yeah. And now there is still another little problem we have. You can leave it like this if you want, but if the object we have here intersects with the points on which our instances are getting created, we have kind of like this weird effect here where all of these instances get pushed toward the inner surface here. And of course you can try to avoid these intersections here, but there are also techniques to, for example, delete these points where the intersection happens. And maybe we can do this with a Boolean node, but there may be another way which uses Raycasting to check if these points are inside this object here. And you can skip this step completely, but let's do it for completion purposes. So we want to delete these points here when these are inside this mesh. And how can we do this? We can do this with a Raycast node. So Raycast. And here we simply check if the direction of this instance, in this case it may go like this, you can see it maybe here a little bit better. If a ray of this direction hits a surface, and then check the normals of the surface, and if the normals are pointed kind of like in the same direction, we want to delete this point, because then we can conclude that this point is inside another mesh. And of course these meshes here need to be a closed mesh, so otherwise it won't work. So for example, if we have a point here and we shoot a ray like this, we have a normal that may go in this direction, and if we take the dot product of these two vectors, so vector 1 and vector 2, and the dot product gives us a value which is greater than 0, it means that these vectors are kind of like phased in the same direction. So if we have, for example, a ray shooting at the surface here, and the vector, so the normal vector, points in this direction, the dot product will give us a negative value, and in this case it won't delete this point, only if it hits a surface from the back, so to say. So let's quickly delete these annotations and back in our geometry node tree we make a little bit more space, and then we use the target geometry again, our collection. And for the ray direction, we use the normals we have right here. And then we check the hit normal against this normal with the dot product math node. And if this value here is greater than 0, we want to delete these points. So I use a delete geometry node. And to compare this value, I can use a compare math node. It's the wrong node again. I want this, and it's already set to greater than 0. Then I can simply feed this value in here. So right now it should delete these points, and maybe we can just change the visibility of this icosphere here to wire for now. And look at this. Yeah, so you can see that these points are getting deleted. And like I've said, if we not have a closed object like this, it may give us a wrong result. So you have to keep this in mind, or have to use other techniques. But in my case, I found that this works okay. So right now, if we look at the result again, you can see that these points which first created us some problems are now getting deleted. So yeah, that's basically the whole setup. And now I only want to do some polishing, maybe animate this a little bit, and also test the setup on a plane to create like this grass effect. So first, for the animation, I think after realizing our instances is a good point to do this animation. So here we use a set position node and a noise texture. And if we plug this noise texture straight into the offset, you can see that it gets offset only in one direction, and that's because this value here goes from 0 to 1, and we want to remap it in the range of -1 to 1. And we can use a map range node, for example, but we can also use a vector math node. And here we use the multiply add, which does 2 operations with 1 step. So we multiply it by 2 and then subtract 1 from it. And now we control the strength with the scale vector math node again. And here you can see that this is the influence of our noise texture. And I want to scale this down a little bit, so maybe 0.5. Yeah, this looks good. And to animate this here, I simply switch it to 4 dimensions, and then we can animate the W dimension, which is the 4th dimension. And for this I use the scene time node. If I plug this straight in here, the result may be a little bit fast. Yeah. So we use multiply math node to control the strength. And let me test it. Yeah, this looks okay. And now it looks like this kind of windy effect. And the displacement does also work. Yeah. And of course there is a little problem, and you may not see it, but if I decrease the density, you see it here that the start of our curves gets moved, but it should be fixed on the instance of sphere. So again, we need the curve factor. So we use this spline parameter node in combination with the scale node, and then simply use the factor for the scale. And now you can see that the base is fixed on the surface. Yeah. So I increase this again like this. Yeah, looks cool. So lower the speed a little bit. Yeah, like this. And now let's test our setup with a plane. So I simply need to change this object here with a grid. So like this. And then I increase the scale a little bit. And yeah, so you can see what's happening. So I change the visibility to solid again. And now we can, for example, place objects in the grass. And if we change the influence again, so we can do it right here where we do the rotation, and also right here where we do the point displacement, we can achieve some really nice effects. So here's the file I showed you at the beginning, only with a grid instead of a sphere object. And you can see that it is a really cool and useful effect. And yeah, it may create some minor errors when moving objects, but especially for static objects, it's really good. So yeah, I hope you've liked this tutorial, and see you next time.